So hi friend, today we will discuss introduction of an algorithm. So today is the agenda for this algorithm is introduction of algorithms. In this session, we will cover algorithm introduction, properties of algorithms, what are the basics steps to design an algorithms, and what are the different designing techniques. Question is, what do you mean by the algorithms? So in your daily life, you have just have different your set of you can say the schedule. If you have schedule in a systematic way from your morning to the evening, so you can create algorithm for that. Algorithm is the combination of sequence of finite steps to solve a particular problem. So here this is the algorithm for addition of two numbers. Here first we have taken two numbers, then we have store A plus B result into C, and finally we are returning the result of C. So here first most important point we have to consider, that is the combination of steps should have a relation. Okay. So what does it mean? First you have taken two numbers A and B, right? Then you are storing A plus B result into C, and finally you are returning the result of C. You cannot do in that way. You have taken two numbers A and B and you are returning the result of C. So here every combination of two steps should have a relationship, right? First you have to take in number A and B, then after you can store A plus B result into C, and finally when you have the result of C, then you can return the value of C. Okay. So this definition is taken from the Corman, right? This is the Corman algorithms definition. An algorithm is any well-defined computational process that takes some value or set of values, right? Just consider this point. That should take some value or set of values as input and produce some value or set of values as output. Thus, an algorithm is computational steps that transforms the input into the output. So you can also see in this example, okay, here you have set of values as input. You are giving that values set of values into the algorithms, and finally you are getting some values as output. In this example, this set of input values as unsorted number. Okay, that is unsorted numbers. Algorithm wise, we have taken any sorting algorithm. We are not focusing which kind of algorithm, but this is unsorting algorithm. And finally, we are getting sorted number. Okay. So here we are taking some values as input, and our algorithm provides some values as output. Just consider any searching algorithm. Suppose linear search I'm talking about. So in linear search, we have some input. Suppose 1, 3, 2, 5, 9. Okay. We are giving this input into these algorithms, and we are trying to find the value of 5, and finally we are getting whether 5 is available in this uh, list or not. So here we are giving set of values into the algorithm, or we are getting a value as output. So these are the properties of an algorithm. So these are the basic properties of algorithms you have to consider. First one is input. So our algorithm should take zero or more number of input externally, right? Externally means through keyboard. If you are talking about the previous example, you are giving A and B value through the keyboard externally. So our algorithm should take zero or more number of input externally, right? The second property is output, right? So output means our algorithm should produce at least one output. In case of sorting algorithms, we are giving some values as input and we are getting set of values as output, right? And in case of linear search, we are giving set of values as input and we are getting a value as output. The next property is definiteness. So definiteness means every steps in the algorithm should be clear and unambiguous. Should be clear and unambiguous means suppose we have one statement, right? X is equal to y plus z minus w. Okay. So you know plus and minus have same precedence. So here first should be y plus z or z minus w. If you don't have some rule, we are same precedence and we are just considering the value from right to left or left to right. That is as that is mentioned in the compiler, right? So compiler can identify this because we have set this rule. Uh, if two operator have same precedence, then we have to consider from left to right or right to left. That depends on the compiler. But here, uh, if we don't this kind of rule precedence rule from we have to consider from right to left or left to right, then you know this plus and minus have the same precedence, right? So you cannot do y plus z or z minus w. So this is this is ambiguous step. This is ambiguous ambiguous steps. Okay, so how you can make this unambiguous? So you can do in this way y plus z minus w. So you know this open and close bracket has the higher precedence as compared to minus. So obviously y plus z first it should be calculated and after that the value should be subtracted as w in this value. So this is unambiguous step. So next is finiteness. Okay, finiteness means if we trace out the instruction of algorithm, then for all the cases the algorithm will terminate after a finite number of steps. So if our algorithm have 10 number of steps, then it should be our algorithm should be terminate after executing this 10 number of steps. Our algorithm should be terminate after a finite number of steps. Okay, it will not take infinite number of time as well, right? So that is a finiteness. And the next is effectiveness. Effectiveness means uh, it must be possible to perform each steps of an algorithm exactly and in a finite amount of time. As I told earlier, this finiteness means our algorithm should have finite number of steps, right? What effectiveness means that steps should be executable in a finite amount of time. That means our sum of steps should not take infinite kind of time or this maybe that take much time, right? So the time amount should be finite, right? So that is the effectiveness. So I think you have understood the difference between finiteness and effectiveness. Finiteness means our algorithm should have the finite number of steps, and effectiveness means each and every step should be should be executable in finite amount of time, right? And the next property is generality. Generality means the procedure should be applicable for all problems of the desired form, not just for a particular set of input values. So that means our algorithm should be generic, right? That should not be depend of a particular set of data. So just take an example of binary search. So you know binary search can be applicable only for sorted data, right? Or for sorted numbers. So you cannot apply binary search on the unsorted numbers or unsorted values, right? So in that case, that is a condition, that is a constraint for binary search. So that is not a generic kind of thing, right? So just consider this binary search as an example. So Whenever we designing an algorithm, so that's if we are talking about a problem, so that algorithm should be applicable of that kind of problem as well, right? That kind of problem category. So as I discussed, these are the properties of algorithm. You can have a look for this: input, output, finiteness, effectiveness, and generality. These are the steps to design an algorithm, right? We will discuss this. What are the steps to design algorithm? So first step is problem definition. So problem definition means whenever you are planning to design an algorithm, so first you have to consider which kind of problem, and for that problem you are designing algorithm, right? So problem definition means you are looking what are the input values and what will be the output values for that algorithm, right? For the problem. Okay. So for that particular problem, what are the input values and what will be the output? So based on that, you have to design an algorithms, right? So second is condition to be satisfied. Condition to be satisfied means if there are any preconditions, any condition that should be applicable for that kind of problem for which we are designing an algorithm, right? Just consider example of again this binary search. So for binary search, you know the precondition is the value, the input data should be in sorted order. Then you can design binary search algorithm. If we have such kind of constraints, such kind of precondition, then we have to satisfy that condition. The next is propose any designing technique. After identifying what are the preconditions, what are the conditions to be satisfied, then we will propose a designing technique. If we are um, designing a sorting algorithm, right? So first we have to identify which kind of input data we have. Then if there are any precondition or not. Based on that, we have to propose a designing technique. If we are such kind of problem where we can divide that problem into sub problems, again, if that sub problem is directly solvable or not, then again we have to divide that sub problem into again sub problems, right? If we have this kind of data or this kind of problem, then we can propose divide and conquer approach for that. So propose and design technique means we have different kind of designing techniques: design, divide and conquer approach, greedy approach, dining programming approach, branch and bound backtracking. So we have to propose any design technique based on our problem. The next is represent the flow chart. So after proposing the design technique, we can represent our solution with the help of flow chart. You can say we can identify or we can validate our solution with the help of flowchart. Next is validation. Validation means based on the input and what will be the output, we have to validate our algorithms with different use cases. If our algorithm is satisfying all the use cases, then we can say, yeah, this is the algorithm for our problem. After validation, we have to implement our algorithm, right? By using any programming language, whether we can take C, C++, or Java based on your competency on that particular language. You can implement that algorithm in any programming language. After implementation, then the last one very important step is analysis. So if you whether your algorithm is efficient one or not, that is you can do based on analysis, right? Just take an example. Suppose, just take an example. Suppose we have a problem P and we have designed two algorithm for that, right? Algorithm A1 and A2. So problem is same. You can say we have taken a problem as sorting algorithm, right? We have designed two algorithm A1 and A2, right? And this sorting algorithm A1 have this kind of complexity n square plus 2, and second algorithm A2 has complexity NQ plus 2. We have the same problem. We have two different algorithm A1 and A2 and both have respective complexity. Okay. Now we have to analysis which algorithm is good based on the performance. You know this fn is function of quadratic function, right? That is order of n square approximately. And the function of gn is cubic function. So it is clearly visible. Algorithm is A1 is efficient as compared to A2, right? So uh, you will consider algorithm A1. So this is the analysis, right? For this we have different method to analysis of this algorithm. We will discuss in the coming lectures for the same. So as per the designing uh, steps, so our target basically there are two focus area for that. The first one is designing approach and second one is analysis. So these are our target for designing an algorithms. What are the designing approach and analysis? So these are the designing techniques as I discussed. First one is designing, first one is divide and conquer approach. Second one is greedy approach, dynamic programming, branch and bound, and backtracking. Along with we have some advanced algorithm as well, randomization and approximation that also be used. So these are the reference book I always use. So you can also go through these two books. These are really uh, nice books for learning algorithms. So thank you watching this video. You can like, share, subscribe my video on my channel, and you also comment your suggestion you have. If you have any uh, doubts, any problem, then you can write in the comments and I will read those comments and accordingly I will reply. Okay, thank you.